Okay, we'll begin with Bayes' theorem here. So in this question, it says 60% probability that the economy will outperform, and if it does, there is 70% probability stock will go up. So 60% probability economy will outperform. And if it does, then there is 70% probability that stock will go up. Stock will go up. That means 30% probability that stock will go down. Okay. And here 60% outperformance means 40% underperformance. There is probability 40% probability that the economy will underperform. If it does, there is 20% probability that the stock will question. The stock in question will increase the value. So 20% still stock will go up, and then 80% stock will come down. Okay. So now, first of all, before getting into Bayes' theorem, we will see what is the, see, this is called unconditional probability, the one that is happening first. Okay, unconditional one. So outperformance. If it happens, then only stock will go up. You know, there is 70% chance that the stock will go up. This is called conditional probability. Similarly, this is unconditional because it is not dependent on anything. 40% probability. If it happens, then 20% probability that the stock will go up. So this will become conditional. This is conditional. Okay. Yeah. Then, so now if I want to calculate, so what happens in Bayes' theorem is basically we will make conditional, as unconditional, and we will make unconditional as conditional. That means if stock is going up, then what is the probability of economy outperformance? Okay. So what is the probability of economy outperformance then? So now I want to find out what is the unconditional probability of stock going up. What is the unconditional probability? What is the unconditional probability of stock going up? Okay, so stock is going up here as well as over here. Okay, so but these are all conditional one, and I want to make it unconditional. So unconditional means what? That if the outperformance happens, still stock goes up, and if you know underperformance happens, still stock goes up. So in both the cases, stock should go up. So if outperformance happens, okay, so 60% into 70%, or 40% into 20%, this part. So that means I have covered the fact that stock is going up, irrespective of whether it is underperformance or outperformance or underperformance. This is underperformance. So I have covered both underperformance as well as outperformance. In both the cases, stock is going up. That I have covered. So this becomes what? Unconditional probability of stock going up. Okay, this is unconditional outperformance. This is unconditional underperformance. Both I have covered. In both the cases, stocks are going up. Okay. So this is 42 percentage plus 8 percentage. So 50 percentage probability that the stock will go up, unconditional. Similarly, if I want to calculate what is the probability, what is the unconditional probability of stock going down? Okay. What is the unconditional probability of stock going down? So that will be stock going down here and going down here. So unconditional means irrespective of whether it is outperformance or whether it is underperformance. So stock going down 30 percentage and outperformance is 60 percentage. So 60 percentage into 30 percentage, or else 40 percentage into 80 percentage, this part. Okay, so this becomes 18 percentage plus 32 percentage, which is 50 percentage. Okay. Yeah. So we could have found out here itself, like the probability of stock going up, unconditional probability of stock going up is 50. So the unconditional probability of stock going down is the remaining 50. But that remaining 50 only we have found out this way.
Okay.
Okay. Uh, yeah. So now this is unconditional probability. So yeah. Now coming to Bayes theorem. So I'll write this again. So 60 percentage outperformance and 40 percentage underperformance, then 70 percentage stock going up, 30 percentage stock down, 20 percentage stock up, 80 percentage stock down. Okay. Now you see total probability. So this is probability of A and this is probability of B given A. Okay, and this becomes total probability of A intersection B. This step is okay, what I have written now. So probability of A intersection B is equal to probability of A and probability of B by A. Okay. Now, if I make this second part, stock going up, as the you can put yourself to mute, Shravani. So if I make this conditional as unconditional, so that means I will bring it here, and I will make this unconditional as conditional, so I can bring it here.
Hello.
Hello?
Yes.
Did you understand all this, or you missed somewhere in between this one?
Yes, I understood.
Okay. Okay. Then next, covariance. I believe you know all this, right? Covariance, variance, all these stuffs. Or if you want me to recap anything, you tell me. Okay. This is just formula based one. It looks big, but it is very easy one. Okay. So very easy means how. Uh, so so here. Um, like for example, if I do this one now, I will not do the entire sum, but I will give you the idea. See, domestic stocks, domestic bonds, international equities. $470 and $450. This is the uh, these are called what? Covariance with the same one. That means domestic stock to domestic stock. This is called variance. Covariance with itself will become variance. Okay. Rest all are proper covariance. So for the rest, I'll give another color. Hmm. So just like how we do for standard deviation of your portfolio for two assets, it is weight 1 standard deviation 1 square, weight 2 standard deviation 2 square plus weight 1, 2 into weight 1, and then standard deviation will go away if I'm using covariance. Weight 2 into covariance of 1 comma 2, right? This one. Ah, this one. So in the same way, I will make this as weight 1 standard deviation 1 square plus weight 2 standard deviation 2 square, then weight 3 standard deviation 1. Now it is between 1 and 3 plus 2 into weight 1 into weight 2 into covariance of 1 comma 2 plus 2 into weight 3 into covariance of 2 comma 3 plus 2 into weight 3 into weight 1 into covariance of 3 comma 1 or 1 comma 3. Just you have to then plug in the numbers and then do this. Okay. So here this is standard deviation. No? So here already see weight is given in the question itself. So weight is here, it is given 30, 60 and 10. And standard deviation point of view, here this is variance. Covariance with itself will give you variance. Okay, so if this is variance is 400, standard deviation will be 20. So root of that number you take 20 and then weight and then whole square. So this way we can do. So you take root of 30, that will come over here, standard deviation. Root of 450 will come over here. Fine, okay. Then moving ahead. Covariance of returns from a joint probability. Okay, so joint probability as in so the number here in between is the probability, the joint probability for both. So normally covariance's formula is what? Covariance is equal to summation of x minus x bar into y minus y bar divided by n minus 1. Okay. So yeah. But when probability is given, this will go away. Okay, n will go away and then probability will come in the numerator. So that means here it will be x minus x bar. No? So first I need to calculate what is a bar and b bar. So a bar will be 20 percentage plus 12 percentage plus 5 percentage divided by 3.
12.
So that comes to okay. Acha, 1 second. No, they have given weight also. No? So this will be equal weight. I should not take equal weight. I should take according to this weight or probability. So it should be 20 percentage into 30 percentage plus 12 percentage into 15 percentage plus 5 percentage into 20 percentage. Just calculate this one. So 1 second. This is not 15. This is 50 percentage. 50, not 15.
Point 13.
Yeah, so that is for 13 percentage. Similarly, you will do for second one also. So second one is 30 percentage into 30 percentage plus 10 percentage into 50 percentage plus 0 into 20 percentage. Okay. So now after this, going by this formula, so probability is first is 30 percentage of x minus x bar. X is 20% minus 13 percentage into y minus y bar. Y is 30 percentage minus y bar is 14 percentage. I'm directly taking here, plus next is again x minus x bar into y minus y bar. Okay. Next is 50 percentage. 50 percentage of x minus x bar. So second one is 12 percentage. 12 percentage minus 13 percentage into y minus y bar. Y is 10 percentage minus 14 percentage plus 20 percentage into x minus x bar 5 percentage minus 13 percentage. Now y bar is 0 percentage. So if you solve all this, that's it. That is the answer. I will not be solving everything. Just I'll check the steps because you can try this later on. Yeah. 20 minus 13 into 30 minus 14, 50. Okay, this is the step. Okay. Then going to the next one. Roy's safety first formula. Here, you remember the formula?
Yes, sir.
Roy's safety first ratio is equal to, what is the formula?
Expected return minus
Threshold level.
threshold level upon standard deviation.
Yeah, threshold RL. So threshold level by standard deviation of the portfolio. Okay. Now higher the ratio, better. Now if they ask you probability that the portfolio value will, okay, if they ask this one, then all you have to do is convert this answer into whatever you get. You have to put minus sign. Shortly, if I tell you, you have to put minus sign there, and then you have to find out its probability. This will behave like Z score. This will behave like Z score. So you have to go to that table, quant table, Z table, and then from there you have to find out the probability of not meeting the threshold. Okay, the probability of not meeting the threshold. Like for example, here it is 0.5. So I will take as minus 0.5 here, minus 0.5. So minus 0.5 table I will check, and then I will find out the probability. So in this case, for negative 0.5, it is 30.4. So negative 0.5 means again it will go like this: 0, 1, 2, 3. So minus 1, minus 2, minus 3. So minus 0.5 will come somewhere here, no? Here. Okay. So this part, not meeting the threshold. is this part. Okay.
Okay.
Simulation methods. Okay. Now log normal distributions. So this is the formula. Now I told you, I think last time, as future value is equal to present value into e raised to rt. The same one only given here.
Okay.
Then Monte Carlo simulation. So here some keywords. This is an important one. Okay. So here some keywords are repeated. You know, uh, repeated many times. Okay. Here, these are some keywords I'm highlighting. Hmm. Huh. So later on, you just read all this. I have highlighted some of the key points. Okay. Monte Carlo simulation, a repeated generation of one or more risk factors. That means the key word or the key variable is taken into consideration, and then its different probabilities are factored in. Okay. Finally, it will give you the expected return only, inference about the expected mean. Yeah, this one also. Okay, so here again, these are all theories only. This also you may read later. Probability sampling, under that random sampling, then non-probability sampling. So no, probability sampling includes systematic sampling, stratified random sampling, cluster sampling. Non-probability sampling includes convenience sampling, judgmental sampling. Okay. Then standard error. Okay. Now I'll directly go to hypothesis sums. I think these are all theories that you should be able to read and do. Yeah, hypothesis testing now. So null hypothesis, alternative hypothesis. Okay. So null hypothesis means what? Null means no change. Basically, no change. Null. Okay. So no change means we say it is equal to 0. Alternative is not equal to 0. Okay. So null is, this is the general belief. Null hypothesis is the general belief. Say for example, Parle G biscuit has 100 grams. That is the general, it weighs for 100 grams. This is the general belief. Okay. So it will always have equal to sign. Okay. So I can even say this one also, less than or equal to 0 or less than or equal, let's say 10. 10 here it means 10 minutes. Like Zepto delivers within 10 minutes. Okay. Alternative will be greater than 10 minutes. Okay. Then it can even be null, can be greater than or equal to also. So greater than or equal to means what? Say for example, Mr. A is giving exam and he has always scored more than 70 percentage. Alternative is no, he is not scoring always more than 70 percentage. Okay. So null will always have equal to sign. Alternative will not have equal to sign. Okay. And then type 1 and type 2 error. Okay, so here before that, so this is a bell-shaped curve, and this is telling you the probability of your data falling. So this is standard deviation 1, 2, 3, and left hand side -1, -2, -3. This covers 34% and 34%. So total 68%. Okay, and then this is 16, 13.5, 13.5%, 13.5%. So total this covers 95%. This is 2.5 and 2.5. So this will cover 100%. In fact, 99.95, but let's just round up to 100%. Okay. So this also you should know. Okay. Then now what is type 1, type 2 error? So type 1 error means what? See, type 1 error is, now what will be the output when you do research? That, say for example, Parle-G biscuit is 100 gram. That is the null hypothesis, is equal to 100 gram. Alternative is not equal to 100 gram. So they are lying. Okay. So the output will be accept the null hypothesis when it is true. After doing the, the research, after doing the research through this, you will find the, you will use this formula x minus uh, x minus mu divided by standard error with this formula. So x minus mu divided by standard error is equal to standard deviation by root n. Now whatever number you get, if this number falls outside the range. Now what is this outside the range? First of all, then I will come to the error. Outside the range means, say for example, this is minus, or this is 5. Okay, so now when you are doing this research, you can do with 100% confidence interval. Sorry, not 100, 90% confidence interval. Okay, or 95% confidence interval, which is the most common. 95% confidence interval, because your survey cannot be 100% sure, right? Okay, 99% confidence interval. So for 90% confidence interval, 95 and 99. For 95, it is 1.96 plus or minus standard deviation. Okay. So what does that mean? That means 0, 1, 2, 3. -1, -2, -3. So 1.96 standard deviation means till here, almost 2. Till here. Okay, 90% confidence interval is 1. This is 2.56. No, this 58. Okay, that means it will come till here. 2.58. This one is 1.90% confidence interval. I forgot. You remember 90%? 1.65, 1.65 only that was, yeah. 1.65 plus or minus 1.65. So 1.65 will come minus here, somewhere here. Okay, 1.65. So if I go for 95% confidence interval, okay, so that means 95% confidence 1.96. Okay. So yeah. So here, so we will find out, this will give us the Z score, like this is 5. So if this 5 is falling, this is falling outside this number, right? So when it is falling outside this range, then we will reject the null hypothesis. Okay. And if it is falling within the range, we will accept the null hypothesis. Okay. That means it is, accept means it is 100 gram only. It is correct. If it is falling outside, then it is not equal to 100 gram. Now the output, can be, there can be 4 output. One is accept the null hypothesis. When it is true, that means it is 100 gram. We are also accepting that it is 100 gram. Ideally, the researcher will not believe in this one, right? He wants the alternative to be proved. Okay, because everybody is believing in this null, right? Everybody thinks that it is 100 gram only. So if the researcher is also thinking is 100 gram, there is nothing to research. Okay, he wants this alternative to be proved. Okay, that's the intention. That is his intention. Okay. But then quite possible that he is wrong and the world is right. That means the null hypothesis is right. So accept when it is true. Another one is reject the null hypothesis when it is true. So reject the null hypothesis when it is true. That means it is actually 100 gram, but you have rejected. Why? Because you have not taken sample properly. So this is called type 1 error. Okay, type 1 error. The next one is accept the null hypothesis when it is false. So that means that 100 gram is false, but you have accepted as 100 gram only. Then this is called type 2 error. Type 2 error. Another one is reject the null hypothesis when it is false. Okay. Yeah. So these are type 1, type 2 error. Then there is another term called power of a test. Power of your test. That is equal to 1 minus 1 minus power of a test is 1 minus probability of type 2 error. Okay, that means how correctly you are able to reject when it is false. Okay, that is called power of a test. These are some terms associated with it. Then coming to hypothesis, this I told you already. So this is the formula that we will use, x minus mu divided by standard error. So this is called as test statistics. This is the test statistics. Okay. Then difference between means. Difference between means. Okay, so when to use this one now? Um, so difference between means. If I want to check if the mean return, okay, so here Sue Smith is investigating whether the abnormal returns for acquiring firms during merger announcement period differ for horizontal and vertical mergers. She estimates the abnormal returns for a sample of acquiring firms associated with horizontal merger and a sample of acquiring firm involved in vertical merger. Smith finds that abnormal returns from horizontal mergers have a mean of 1% and a standard deviation of 1%, while abnormal returns from vertical merger have a mean of 2.5 and a standard deviation of 2%. Okay. Mm. So when we want to check means, when we want to check difference in means, there is difference between the means of two populations. Okay, if this is the intention, difference between the means of two populations, that means we want to check whether, like in this case, the population means are for vertical merger, there is one mean. For horizontal merger, there is one mean, and then for vertical merger, there is one mean. So for two different population, these are two different population, vertical and horizontal. So if you want to check whether those means are same or not, then this is the formula given here. This formula we are supposed to use. So this one, again, it's not very difficult, just like how we saw test statistics is x minus mu divided by standard error in the same line only. It will be x minus or x1 bar minus x2 bar minus, so for this mu, so this is x, and then for this mu it will be mu1 minus mu2 divided by standard error. Now because this is pooled variance they have taken, because here samples are independent and they are taken from two populations that are normally distributed. Okay. Here this is the key point. The key point is this one. A pooled variance is used with the t-test for testing the hypothesis that the means of two normally distributed populations are equal when the variances of the populations are unknown but assumed to be equal. That is the key point. Variances of the populations are unknown, but we are assuming it to be equal. Okay, so if this is the case, then I'll take pooled one. So pooled one is what? This is pooled variance. Okay, P stands for pooled variance. Okay. Then uh, okay, this is pooled variance. and pooled variances formula is also given over here. Suppose if this would have been assumed to be unequal, then the formula would have gone changed to instead of doing like this pooled, I would have written the same thing here, this one copied, and here it will be first one variance and then second one variance. This way we would have changed it. Okay, then the next one is paired comparison test. So paired comparison test here, it should be used when means of two independent samples. Okay, while the test in the previous section was of difference between the means of two independent samples, sometimes our samples may be dependent. Okay, if the observations in the two samples both depend on some other factors, we can construct a paired comparison test. For an example of a paired comparison test, consider a test of whether returns on two steel firms were equal over a 5-year period. So their base will remain the same over here, right? Base as in uh, the samples all will remain the same over here. We can't use the difference in means test because we have the reason to believe that samples are not independent. So when samples are dependent, so this is the key part. When samples are dependent, then what should we do? So if samples are dependent, so in that case, these are few words. It is not there in 2025 book. Okay, I'm using 2026 book now, but slightly better they have explained it over here. Okay, but more or less all same only. So in that case, if samples are dependent, then this is the formula. Okay, so this is here what we did previously was samples are independent. Okay. So samples are dependent. This is differences, sample mean differences. Okay. Yeah. Again, all these videos are already there uploaded. Okay. These kind of videos. But this is the formula. At least the formula you should know. I don't think they are asking outrightly sums directly. Even if they're asking, it will be just plugging in the number only in the formula. Okay. Then okay. This is mean of the population of pair differences. Hypothesized mean of pair difference, which is commonly 0. So this number is 0. This is 0. And this is sample mean differences. That means take difference divided by n. This one. Okay. But these sums are already done, okay? Already there. In the YouTube channel, I have already put this up.
Okay.
You can check there also. This all this from hypothesis onwards, I have already put up. because normally people ask revision from there only. Yeah. Okay, I think now we will stop now here. You just go through, videos are there already in the YouTube channel. Anyways, otherwise also you go through it. Plus, next time I'll just take you through from here onwards, and then I will finish this up. Okay.
Okay, sir.
Yeah. So I'll stop now here. Yeah.
Okay. Thank you, sir.
Okay.
Bye.
Okay.